All right, diving in today. And this is a topic that's been buzzing around my head ever since you sent over those articles.
Yeah.
We've all been wowed by ChatGPT, these large language models, and how they can just spin words, right? It's incredible. But the question that keeps popping up for me is all that linguistic wizardry, is that really the same as actual intelligence?
It's a great question, and it's something a lot of people are grappling with. Jan LeCun, one of the big names in AI, he made this statement that's really stuck with me. He said that even the most advanced language model right now, today, is still essentially dumber than a cat.
Dumber than a cat. I mean, that's kind of a funny image to think about, right?
Yeah, and it's provocative, right? It makes you think, okay, so what's missing? We're feeding these models massive amounts of text data, but there's still this gap between what they can do with language and what we consider genuine intelligence. What's going on there?
Yeah, it's like they're missing something fundamental. So let's dig into that. What are these limitations that researchers are pointing to? What's making them think we need to move beyond language alone when it comes to AI?
Well, the main thing, it comes down to the type of data that these models are trained on. Think about it. LLMs, they're mostly trained on text that's been scraped from the internet. So they become incredibly good at mimicking patterns in language, the way we write, the way we structure sentences, all of that. But they don't really have this deep understanding of the physical world, things like how objects move in space, cause and effect, the basic laws of physics. They don't grasp those concepts in the same way we do.
That's a great point. It's like they can write a beautiful paragraph describing a baseball flying through the air, but they wouldn't actually understand the forces at play.
Right, exactly. It's all surface level. And it really shows you that learning, true learning, it's not just about words, it's about experiencing the world through our senses.
It's like riding a bike, right? You can read all the books in the world about how to ride a bike, but until you actually get on one and feel how it balances, you won't truly learn. So if language alone isn't the full picture, what's the alternative? What's getting researchers excited? And this is where world models come in, right?
Exactly. World models, they're this whole different approach. It's about shifting the focus from primarily processing text to learning through interacting with a simulated environment. Kind of like if you were learning to drive in one of those really advanced driving simulators. You're not just reading about driving, you're actually experiencing a world, even if it's virtual, and learning by doing. So the idea is by interacting with these simulated spaces, the AI starts to develop this intuitive understanding of how things work. It's processing visual information. It's experiencing the physics of this world. It's like building a flight simulator for the AI's brain.
That's a great way to put it. And it sounds like NVIDIA, they're making some huge bets in this direction with their Cosmos platform. What are they actually doing there?
It's really interesting what they're doing. NVIDIA, they're creating this platform, Cosmos, that allows developers to build these incredibly realistic 3D virtual worlds. And they can even use things like images or text descriptions as a starting point. Then they can train AI agents within those environments. So the AI is basically living in this virtual reality, exploring, interacting, learning by doing, kind of like we were talking about with the driving simulator. And they're really going all in on this. They're calling it embodied learning. And they're talking about training runs that total over 20 million hours of video data.
20 million hours. That's an insane amount of visual data. And you see a parallel here, right, with what NVIDIA did in the deep learning revolution.
Yeah, absolutely. Just like NVIDIA's became essential for deep learning, they're now positioning themselves to potentially lead this next wave with world models. They're providing the tools, the infrastructure to make it all happen.
So let's imagine this all takes off. What could AI powered by world models actually do in the real world? What would this mean for, someone listening to this right now?
If you think about the bigger picture, world models, they could lead to AI that's not just smart in a theoretical sense, but smart in a way that actually allows it to function in the real world in a much more sophisticated way than we see today. We're not just talking about AI that can chat with you or write you a poem, but AI that can actually understand its physical environment, make decisions based on that understanding, and adapt to new situations in a way that's more similar to how humans do it.
So while large language models, the LLMs, they're amazing for language, world models could be this crucial step towards a more general type of artificial intelligence.
That's the hope. The LLMs, they've pushed the boundaries of what's possible with language processing, but world models, they're all about giving AI a deeper understanding of how the world actually works. It's not necessarily about one replacing the other. It's more like an evolution towards this more complete, more well-rounded form of AI.
So the key takeaway here is that the future of AI, it might not just be about processing words. It might be about actually learning by doing, just like we do, just like other animals do, experiencing the world and building up an understanding from those experiences.
All right. Simulating reality to understand reality.
And that raises a really fascinating question for all of us to consider, right? If AI can learn these really fundamental things about reality through simulations, through these virtual worlds, what kind of new possibilities might open up? What kinds of things might AI be able to do that we can't even imagine right now? And on the flip side, what new challenges might come up that we haven't even thought of yet is something to think about. Thanks for taking this deep dive with us.